cubed root of x to the 7th power. When we see these cube roots, what we want to do is, to change form, one of the easiest things we'll do all term, divide by the index. Exponent divided by index. And where earlier we even had to divide, what we're saying here is that the radical is the rational exponent. There, I'm done. All I need to do. Try not to overthink some of these problems. What if I had 5th root of 9ab? When I want to say divide by the index, I can't just say 9ab. Well, what is my index? I have an exponent of 1. Divide by my index of 5. I can't just say 1/5 because now it only applies that b. Remember, my entire radicand is the 9ab. And it's still to a power of 1, but I've got to keep that entire radicand, and all I would have is 9ab, in parentheses, to the 1/5 power. That's how I end up with those rational exponents, is just divide by the index. Another example, 7th root of x cubed to the 4th. As much as I want to say x to the 3/7, remember that 3 only applies to the x. What I would really need to do here is, once again, consider the entire radicand as a group, as a quantity. And what I would need to do is I recognize that exponent of 1, still divide by the index, x cubed over 4 to the 1/7 power. Now, this works both ways. If I have x to the 5/2 power, that 5/2 means the same way I can swing an index over as a denominator, I'm perfectly fine to ever want to just swing a denominator over as an index. What this means is the 2nd root of x to the 5th, which we wouldn't actually want to say the 2nd root, because remember the 2nd root of means square root. It wouldn't be wrong, but it wouldn't be simplified. Leaving that 2 in there is the same as leaving a 1 as a coefficient, leaving a 1 as a denominator. If we aren't simplifying, Math Excel will count us wrong, and understandably so. We need to complete the problems in simplest form.